Hello, my name is Sarah. I'm a data scientist at Spring, and I want to show you today how we generate a SEO title in the newsroom. So let's start. Spring. Spring is the we are responsible for the news website, also for news media websites. The main brands we serve are Welt and Bild.de, very large ones in Germany, and especially for Welt, circa about 1/3 of all visitors come through organic search on our website. That means that they search something in Google, something news related, for example, the coronavirus, and they see some interesting news in there. And that even though they don't want to see it on Welt, but they click on this link and land on Welt.de. And responsible for that is the so-called SEO title that namely tells them this is an article you might be interested. First of all, of course, it's listed by Google very high, so you can see it. And then this SEO title tells you what the article is about. So you want to click it. And in comparison to that, the title of the article itself is rather more interesting when you're already on a website and you're curious what you want to read about. Then it has it's rather a creative part of the article itself. So the SEO title contains keywords. It's very informative and is searchable, of course. And that means that when a journalist, somebody has his microphone on, and when the journalist creates the article, the title, the SEO title, they have to shift their mind a little bit. So it takes some time, and also have to search keyword. It takes just time. It's not very interesting for them. So our goal was to help journalists in creation of the SEO title. Of course, I mean, SEO title is very important. We get money from that. And it's not so the core task of a journalist. Before I want to present the project, I want to show that lots of people were involved. A few from Spring, but we also asked data science consultants from AWS to help with that project, and also from As Ideas, Christian Schäfer gave quite a few inputs, and we are thankful for that. So it's a huge project, and of course I have only 50 minutes in total, so it's can only give a broad overview. Let's start with the data. So we started with a huge data set, namely articles and SEO titles since 2014, which is about 3 million articles. But however, in these articles, the SEO titles are often generated automatically by a news agency, and also we were not sure if the journalist did a good job in creating this SEO titles. So we've referred to the SEO team. Of course, we have an SEO team, but they only have limited capacity they cannot touch every article. And we scraped the logs to find roughly 2,000 SEO titles which were touched by the SEO team. So these only 2,000 SEO titles were our gold standard, where we knew, or we could say that they might have a good SEO title. Now, as I told you already, a good SEO title contains keywords and also an understandable title. And because we split those two parts into two work streams. One of them took care for sorting the keywords, and the other one created an understandable title. In the end, we also merged them a little bit. but I won't show that, unfortunately. And I'm mainly concentrating my talk in creating this understandable title, but because the sorted keywords are also interesting, I only want to show very briefly how we approach this problem. We took keywords from the text using Google named entities and Google named entity recognition. And we defined for each keyword different metrics, such as search volume at Google, which you can ask by Google trend, or the relevance for text, or how trending it is at the moment, so some time information. And we use this different metrics to train an XGBoost boost ranking together with our gold standard data to find the correct ranking of the keywords. That's very brief, and I mean, it's just, you can refer to that later. But now let's go to how did we approach to create an understandable title? I mean, that's text generation, and that asks for deep learning. And here we refer to a quite complex neural network, which was published by some students or some colleagues from the University of Edinburgh, where they take input articles and create a short summary. They call it birdsum. And what they usually, it's called birdsum because they use for the text representation a bird which they slightly modified to capture longer text. So we have an encoder which encodes the input article, and a decoder which decodes the output SEO title. I mean, it's a very brief, very complex architecture. It's far too short to understand it roughly. I refer to the paper as well. But just to get you an idea how much this, how large it is, I just put a number. Training of one model takes 3 days on a quite large machine on AWS, and it costs around 400 euros. So it's a big thing. And of course we had some previous experience. And in every stage you want to know how well you model. And the main question is, do we produce good SEO titles? And we went then into lots of trying out lots of different metrics. When you go to text generation, they often come from translation, or they often deal with translation, and then they measure the exact wording. So we have this model, and we want to know if it performs well. And therefore, we tried out different metrics. We first of all tried those ones which are very common in judging translations, but we quickly found out that it doesn't work for us so well, because when you have a summary or one sentence summary, you can say different things in different words. I mean, what we did was always compare the truth, the original SEO title, with our prediction, with our own prediction. And we tried to measure how far are they away from each other. That's the main idea about metrics. And Rouge and Blue Square didn't work for us, but then we tried to find sentence embedding, which were based on on word-to-vec embeddings. We came up with different ones. For example, we calculated the mean distance of most similar words, or we calculated a sentence as a centroid in the word-to-vec space of all words of a sentence. And we even tried out multilingual universal sentence encoder, which is a new model of quite old, from 2017, by Google. But during our first experiment, that worked quite well because we saw we could track a development of the models, and we saw, okay, we're improving in our modeling and stuff. I mean, we have had some kind of development history. But in the end, we found that all these models don't capture very well wrong grammar, and also if we produced a good SEO title, but it didn't have a good, it wasn't compared to the ground to the original SEO title, we had still a quite large difference, although we were working quite well. So that gave us the conclusion might go to a human check. I mean, human check, you always try to avoid it because it's so much effort to do, and you don't never like it, and it's also often a little bit boring. But we sat down and found an environment where we can do those checks. We, for example, decided for different types of articles, and decided also for clear questions we want to ask. For example, is the grammar correct? Is it informative? And there we agreed for on a scale. And also, for example, does it contain false info? Because that would be bad for an SEO title. And here's one of the first experiments what we did for the human checks. And what we see is here the number of SEO titles. And here is the scale from 1 to 5 for informativeness, where 5 would have been, we can publish it right away, and 1 means I have no clue what it is about. So we agreed on different steps, and we see right away that evergreen articles, which contains something like guides or what you do when something happens or something, I don't know. They tend to have a long article and also somehow introductory story, which could not be grasped by our model at all. So it was always confused by the introduction. However, in use, it performed quite well already. So we found out that, first of all, we found limits in our data, in our model architecture, and we might refer then to other architectures. On the other hand, we found during the checks that we have some weird SEO title. I mean, we trained on 500,000 titles in the end, and no one can ever check those by hand. But while we were looking through our by hand through our generated text, we found some patterns popping up, and we found them also, of course, in our training data. But we would have never guessed that they are existing there. For example, here D, Merkel, EU, Turkey, blah 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 blah. Or for sport article had these pattern often, and some things. And that's why I would say human check was extremely helpful in developing this project. Okay, now we have those model. We were quite happy with that, with this first draft. I mean, it's the first one. And what's left to do now? We already produced a pipeline where we somehow semi-automated our training. So, I mean, we're dealing with news, and we have to accommodate new words in a general way, in a frequent way. But that's can be taken care of by the production pipeline now, quite handy. And now we go over to implement the front end. We're almost done, I think, and we go to some news tests if the news editors will like it. I hope they like it, of course, but the coronavirus makes it quite difficult for us to reach them. They're very busy. And if all these things are useful and helpful, we will probably roll it over to build as well. And that's it from my side. It's time for questions, and here are some our favorite funny titles we encountered when we checked the training data set, the test data set.